I'm repeating. Today we are discussing about the fabrication method. The fabrication methods are nothing but where the plastic is converted into plastic article. Okay, we will see the step by step. Now we can have the different classifications of fabrication methods. Now I will tell you some of the main important fabrication methods. And here the first classification is compression molding. Number two, injection molding. Number three is blow filling molding method. In your previous examination, the fabrication method and each method they're asking for 3 marks. Compression method is asking for 3 marks, injection molding is 3 marks, or the blow filling molding for 3 marks. Or we can write for essay question is 8. They're asking the compression molding is a 4 mark and injection molding for 4 marks. Like compression molding is 4 marks and the blow filling molding method is asking for 4 marks. So any combination of the two molding methods in your final examination, they're asking for 8 marks. Now we will see step by step. Let me ask you the question, what is meant by compression molding? You see this diagram. Now I will tell you the compression mold containing different step diagrams. Now we can have the first step diagram. It is known to be that compression mold. I will ask you the question, what is known to be that compression mold? Compression mold is a combination of the two halves. The one should be that upper mold half and there should be that lower mold half. Now we can have the two halves and these two halves are connected by knockout pin or ejector pin. You see this. You can have an ejector pin here or a knockout pin here. Now with the help of ejector and the knockout pin here, now we are combining the upper mold half when compared with that lower mold half. You see this. What is meant by upper mold half? And this upper lower mold half, when we are seeing the combination, we are getting U shape. You see this. When we are taking upper and the lower mold half, the combination what we are getting is U shape. Now, upper mold half is made up of iron. The lower mold half is made up of iron. In between the upper mold and lower mold halves, just I would like to place the charge. I'll ask you a question, right? What is known to be the charge? Raw plastic is known to be the charge. And this charge is nothing but a plastic raw material. Plastics of two classification. The first classification thermoplastic and the second classification thermoset plastic. Simple. In between the lower and the upper mold half, just I would like to place the plastic. Now, this plastic is treated with the force, application of the pressure. Number one is known to be the force. Number two is known to be temperature. Now, when we are applying the force in this direction with a certain velocity, I'm repeating, what is the V indicating that? V indicating that velocity. Application of a mechanical force indicating that F. When we are applying the force with a certain velocity in counter direction, okay? When you're applying in the counter direction with the help of ejector pin, then we are already placed the plastic raw material in between the two halves. I'm repeating. We already placed the plastic raw material in between the two halves. Now this plastic raw material will be squeezed. I'm repeating. The plastic raw material is squeezed. Now, when I'm applying simultaneously temperature, then what happened? The squeezed plastic is converted into molten state. You will see clearly. It is known to be that upper mold half, and this part is known to be that lower mold half, upper mold half followed by the lower mold half. In between the upper mold, lower mold half, just I would like to place the plastic. And this plastic may be thermoplastic. The plastic may be thermoset plastic. Now, when I'm taking thermo or thermoset plastic, just I'm applying volume followed by, sorry, just for applying pressure followed by V. I will ask you one question, right? When we are applying the force on the upper and the lower mold halves in the counter side direction, I'm repeating. When we are applying force in the upper and the lower mold halves in the counter side direction, then what happened? There is a possibility. The possibility what we are saying is mechanical pressing. I'm repeating. Because of mechanical pressing, the plastic which is squeezed. In between, we are placing the raw material, and this raw material should be squeezed. Okay. Next, I would like to apply the temperature. When we are applying the temperature, solid plastic is converted into the molten state. Now the solid plastic which is converted, the solid plastic is converted into the molten state. Now the solid plastic is converted into the molten state at the high temperature. Then we are decreasing the temperature. When the higher temperature come back to the normal temperature, When the temperature decreases, the molten state come back to the solid state. I'm repeating. Now this molten state is converted into the solid state. When the temperature increases, solid state is converted to give molten state. When the temperature decreases, molten state is converted to give solid state. You see here. Then, just I would like to use a zip tar pin in a counter side direction. Just I would like to open the upper mold half followed by lower mold half. You see here. Just I would like to open the upper mold half followed by the lower mold half. Now we can have in between an article, I'm repeating, in between we can have an article and that article should be U-shaped. In between article is there and that article should be U-shaped, right? So we'll see the compression molding process once again. Compression molding process having three-step mechanism. The first step, we should know about the descriptive of compression mold. When you are discussing the descriptive of compression mold, it is a combination of upper mold half and lower mold half. In between the upper mold half and the lower mold half, we are placing charge. Charge is known to be plastic. In the second step, we are applying the force followed by the temperature. Thermo or thermosetting plastic should be squeezed and it is gradually converting into the molten state. When the temperature decreases, molten state is converted to give solid state and it is in the shape of U-shape. I'm repeating. The resultant article which we are getting is U-shaped articles. You see this compression molding contained in the following step. The first step is charge is loaded. The second and the third step is compressed and cured. I'm repeating. The word compressed indicating that mechanical pressing. The word curing indicating that where the solid plastic is converted to give the molten state. Next one. Opening the mold halves. Just you're opening the upper half and as well as lower half. And finally, we are getting article, removing the part of article. Just I would like to remove a part of article and that part of article will be U-shaped. With the help of compression molding, I'm repeating, with the help of compression molding, just we are preparing U-shaped plastic articles. And those U-shaped plastic articles are thermoplastics and as well as thermoset plastics. Now it is about the first classification, compression molding. Now we will see the next classification. Now we are seeing the next classification. The next classification is very, very important. The next classification is very, very important. That is known to be that injection molding method. What is known to be that injection molding method? Injection molding method is applicable for thermoplastics. Just keep in your mind. Compression molding method for thermoplastics, thermoset plastics. Injection molding method for thermoplastics only. Now applying injection molding method. In injection molding method, I'm taking the plastic material. The plastic raw material should be taken along with the hopper. What is known to be hopper? Hopper is known to be entrance. Now, I'm taking thermoplastics here. I'm repeating. Injection molding method is only applicable for thermoplastics. Now, thermoplastic should be taken into heating chamber. Now, it is known to be that heating chamber. And this chamber should be heated with the heater. I'm saying as heating elements. I'm repeating. Now, in the second step, thermoplastic, solid thermoplastic should be heated. When solid thermoplastic is heated and it is converted into molten state. Now the solid plastic which is converting into liquid state. The solid plastic is converted. The solid plastic which is converted into that molten state. Okay, it is known to be second step. In the third step, I would like to use screw conveyor motor. This point is very, very important, right? I will tell you what is known to be screw conveyor motor. When we are applying the screw conveyor motor, the screw conveyor motor injecting, I'm repeating, the screw conveyor motor and this screw conveyor motor is injecting the liquid plastic. The screw conveyor motor which is injecting the liquid plastic through the mold. Simple. The screw conveyor motor which is injecting the plastic through the mold. Now the plastic should be injected through the mold. What is known to be the mold? I'm repeating. The word mold is the thing where the mold containing different shapes. Okay, mold which containing different shapes. That might be shape of a chair, shape of a sheet, or shape of a rod. Okay, when this liquid plastic is injected through the nozzle, I'm saying it is known to be nozzle. The word nozzle indicating that a small way, right? Now, along with that, the small entrance, the liquid plastic which is injected, and this liquid plastic is injected with the help of screw conveyor motor. The liquid plastic which is injected to the screw conveyor motor. Now this molten plastic is injected through the mold, and this mold containing different shapes. This mold containing different shapes. Right? What happened? When we are decreasing temperature, when we are decreasing temperature, then what happened? Molten state come back to the solid state. Molten state is converted to give solid state, and this mold containing, again, this mold containing the two part, and the two parts are connected with a pin. When we are opening the pin, when we are opening the pin, in between the mold we are getting an article. Okay, just I would like to open the mold with a pin. Just I would like to open the mold with a pin. When we are opening this pin, right, just I would like to open this pin, then what happens? In between we can have an article, and that article may be different shape. Let me ask you the question, right? What is the descriptive of injection molding method? The first step you're taking thermoplastic, right? The first step you're taking thermoplastic. I will ask you a question. What is the difference between thermoplastic, thermoset plastic? Thermoplastic, best example, polythene is a thermoplastic, polyvinyl chloride is a thermoplastic, polystyrene is known to be thermoplastic, and these thermoplastics are taken into the heating chamber, right? What is in the thermoset plastic? Thermoset plastics are non-recyclable. Thermoset plastics containing high hardness, thermoset plastics containing permanent hardness. Thermoset plastics are known to be bakelite. Thermoplastics. Polythene is thermoplastic. Polyvinyl chloride thermoplastic. Polystyrene is known to be thermoplastic. When we are taking thermoplastics into the first chamber is known to be the heating chamber, which is heated to high temperature, and I'm applying pressure with the help of screw conveyor motor. I'm repeating. Just I would like to apply the pressure with the help of screw conveyor motor. There are simultaneous application. The simultaneous application is nothing but temperature followed by the pressure. I'm repeating. When we are applying temperature followed by the pressure, now we can have here is a liquid plastic, and this liquid plastic is slowly injected. I'm repeating. The liquid plastic which is slowly injected. The liquid plastic which is slowly injected along with the nozzle. The liquid plastic which is slowly injected along with the nozzle to the mold, which is injected to the mold. And this mold containing different shapes, and finally we are getting different types of articles. Okay. The process what we are saying as injection molding method. Okay. Next one. Now we will see the next classification. The third classification of molding methods, it is known to be that blow filling molding method. I will tell you what is in the blow filling molding method. The blow filling molding method, we are preparing only thin plastics. I'm repeating, and it is applicable for thermoplastics. There are the two conditions. The first condition, the process is applicable for thermoplastic. The second condition, with the help of blow filling method, I'm repeating, with the help of blow filling method, we are preparing very thin plastics, right? We are preparing the thin plastics like bottle. Bottle is the best example for thin plastic. Plastic cover is the best example for thin plastics. And all these types of the plastics are prepared with the help of blow filling method. Now we will see what is in the blow filling method. And this blow filling method containing hot air pumping machine. I'm repeating. Okay, I will tell you what is this hot air pumping machine. And it containing mold. I'm saying it is known to be that mold. In this mold, I'm taking raw plastic, and this raw plastic is heated to high temperature. When we are heated to high temperature, and this thermoplastic is converted into molten state. I'm repeating, thermoplastic which is converted into molten state. Then what happens? To the molten plastic, to the liquid plastic, I would like to treat with hot air. This point is very, very important. In the blow filling method, in the blow filling molding method, I would like to treat with hot air. When the liquid plastic is treated with the hot air, then plastic will be expanded. I'm repeating. And this plastic will be expanded. The plastic will be expanded in the mold, just like a balloon. Okay, just like a balloon. When we are pumping hot air, when we are pumping the hot air, then what happens? The liquid plastic will be expanded. The liquid plastic will be expanded. The expanded liquid plastic seems to be like a bottle shape. It seems to be like bottle shaped. Now this bottle shaped plastic, which seems to be very thin. So when you are explaining about the blow filling molding method, the blow filling molding method is applicable for thin type of plastics. I'm repeating. Blow filling molding method is applicable for thin type of the plastics. And this blow filling method converting a plastic raw material, and this plastic raw material is thermoplastic. Thermoplastic is heated to high temperature. It is converted into the molten state. When we are pumping with the hot air, I'm repeating, this point is very, very important. When we are pumping with the hot air, then what happens is the plastic which is converted into a thin plastic will be expanded. Now, and this mold is having the shape of a bottle. Now see here, this mold containing the shape of the bottle. During the expansion process, plastic is converted into bottle shaped. Plastic which is converted into the bottle shaped. The bottle shaped plastic in the molten state, when we are decreasing temperature, when the temperature decreases, molten state come back to the solid state. Molten state is come back to the solid state. The solidified plastic is in the bottle shaped. I'm repeating. The solidified plastic which is in the bottle shaped, which is removed with the help of zip-tar pins. Okay. Now I would like to separate the molded bottle. Just I would like to separate the molded bottle and the bottle containing thin nature, and this bottle containing thin nature. Then thin plastic materials, I'm repeating, once again I'm repeating, thin plastic materials. Thin plastic materials are prepared with the help of blow filling molding methods, right? Now it is known to be the third classification. Now, once again, we will see the three main classifications. The first classification, compression molding. The second classification, injection molding. And the third classification, blow filling molding method. Compression molding method is applicable for thermoplastics, thermoset plastics. Injection method is applicable for thermoplastics. Blow filling molding method is applicable for thermoplastics. Next one. Compression molding method, the process where we are applying force, I'm repeating, the force followed by the pressure. The method what we are saying as mechanical pressing. Preparation of plastic article by mechanical pressing. Okay, with the help of upper mold half and as well as lower mold half. With the help of upper lower mold half, we are preparing the plastic by the mechanical pressing. The process what we are saying is compression molding. Now, what is the drawback of compression molding method? The drawback of compression molding method is nothing but compression molding method is only preparing cylindrical shaped, handle shaped or U-shaped articles, right? Now see this, manufacturing of cylinders, manufacturing of handles, and manufacturing of U-shaped articles. Now, the preparation of number of articles, the probability will be the very less. And this property or the process of preparation is only applicable for thermoplastics and as well as thermosetting plastics. Now, when we are seeing the second classification, what we are saying is injection molding method. Injection molding method is applicable for thermoplastics. The process, what we are saying is pressure followed by the temperature. The first step, you're applying the heat. I'm repeating. The first step, you're applying the heat, where the plastic is converted into the molten state. Plastic is converted into the molten state. In the second step, you're applying the pressure. Pressure is applied with the help of screw conveyor motor. When the temperature followed by the pressure is applied, then what happens? Plastic which is injected to the mold, and this mold containing different shapes of articles. Different shapes of thermoplastic articles are prepared. The more number of thermoplastic articles are prepared with the help of injection molding method. This method is characterized by high speed production and low mold cost. The main advantages of injection molding method is high speed production. That means we can produce maximum number of articles with a stipulated time. The second one, the low mold cost. The cost of that mold is also very less. Next one. What is the disadvantages is when we are applying this method, there is a limitation. The limitation is nothing but designing of articles. The designing of articles during the process becomes a little bit difficult. That is the first drawback. Next one. Now we're discussing about blow filling molding method. Blow filling molding method, it's only applicable for the plastics of bottle shaped, the plastics of a cover, the plastic of sheet. Sheet is the best example for thin plastic, cover is the best example for the thin plastic, and bottle is known to be the thin plastic. The various shaped thin plastics, I'm repeating, the various shapes of the thin plastics which is prepared by the blow filling molding method. In your previous examination, and these three questions asking very frequently, compression molding method, injection molding method, blow filling molding method. Compression molding method is applicable for thermoset plastics. injection molding method for thermoplastic materials, and the blow film molding method for blow film molding method for thermoplastic materials. Now we will see the first classification. It's going to be the molding methods of the plastics. In the continuation, now we're discussing the next question, which is asking very frequently in your previous examination. That is nothing but biodegradable polymers. Okay. In your previous examination, this question is asking for 7 marks and very frequently. In R19 declaration, that might be R16 declaration, that might be R10 declaration. This question will be very, very important. Now discussing about biodegradable polymers, most of the polymers are, or 90% polymers are non-biodegradable. I'm repeating. What is the main setback of the polymer? Whether you're taking a thermopolymer, whether you're taking a thermoset polymer, just like polythene, polyvinyl chloride, polystyrene, or bakelite, any material which is prepared by thermoset, which is non-biodegradable. I'm repeating, 90% plastics are non-biodegradable. Then, what is the setback of non-biodegradable? The degradation, it may take thousands of years. Okay, I'm repeating. The degradation in the soil condition, water condition, and the air condition, it may take of thousands of years. The first drawback. The drawback of non-biodegradable when we are discussing, when we are dumping polythene car in the environment is polluted. Okay. The fertility of the soil completely spoils with the help of non-biodegradable polymers. So everywhere we are saying that plastic should be banned. The entire world having the slogan, let us avoid polymer. But I would like to ask one question that we cannot live without plastics, right? Plastic become a part of everyday life. The plastic become a part of everyday life. We are using plastic cars, plastic bag, plastic bottle, plastic for usage purpose, plastic for industrial purpose, plastic for domestic purpose. Without plastic, the life becomes very, very difficult, right? Now I'll ask a question, how we can replace the plastic of non-biodegradable with biodegradable? Just I would like to use a bottle, and this bottle is made up of PET, polyethylene terephthalate, right? PET bottle. And these PET bottles are non-biodegradable. Then what happens? When you are using a bottle for several years, the bottle that might be react with water, or we are using any food container for several years, the food that might be react with the plastic. I'm repeating. The plastic that might be react with water, plastic that might be react with food, then what happens? There is a possibility of contamination. So there should be a needed for biodegradable polymers, right? What is known to be the biodegradable polymers? When we are discussing about biodegradable polymers, and these biodegradable polymers are prepared from natural sources. I'm repeating. The first main advantage, biodegradable polymers are taken from natural sources. And this biodegradable polymers have two classifications. The first classification is hydrobiodegradable polymers, and the second classification, oxy-biodegradable polymers, right? Now, what is meant by biodegradable? Biodegradables are natural biodegradable polymers mostly. And these biodegradable polymers, they're also prepared in the laboratory. There are the two main classifications based on the process. The first classification is HPP, the second classification OBP. The word HPP indicating that hydrobiodegradable, the OBP indicating that oxybiodegradable. That means when we are using the plastic after the usage, when we are dumping in the environment, during the hydrolysis, it's completely degraded. The word oxy is indicating that when we are dumping the plastic in the environment containing oxygen, during the oxygen condition, the plastic is completely soluble. Plastic is completely miscible. The plastic is completely degraded. That means the plastics are degraded by the two conditions. The first condition is hydrolysis condition. The second condition is oxygen condition. The first one I'm saying is hydrobiodegradable. The second one is known to be oxybiodegradable. Now we will see the classification here. Now, when we are discussing about hydrobiodegradable, and these plastics are prepared from agriculture sources. I'm repeating. The plastics are taken from the agriculture sources. What is the agriculture sources? Just like wheat, just vegetable wastage, and etc. and etc. The agriculture sources, right? They're containing hydrobiodegradation character. They can easily soluble in the water. The byproduct is also known to be carbon dioxide and as well as H2O. 99% polymers are non-biodegradable except HBP and as well as OPP, except biodegradable. Next one. What is known to be OBP? The word OPP indicating that oxy-biodegradable polymers. when I'm discussing about oxo-biodegradable polymers, and these polymers are degraded by the oxidation condition, environment containing oxygen, right? Then, and these products are very free from oil and as well as natural gas. Now, when it is oxidized, the byproduct will be carbon dioxide as well as H2O. Then, what is the main advantages of biodegradable? The main advantages of biodegradable polymers are non-toxic. Very, very important, right? Just I would like to use a bottle made up of biodegradable. Best example, Tupperware bottle, right? Then a food material, a food box is made up of biodegradable. It doesn't react with the food. It doesn't react with the water. There is no toxic character. 100% eco-friendly character, which can easily degrade it after the usage. After the usage of the lifetime of the plastic, just I would like to dump in the environment. There is no environmental pollution. The first main condition, they are known to be 100% eco-friendly. I'm repeating. What is known to be eco-friendly? The word eco-friendly indicating that they are non-toxic. It doesn't react with the water, it doesn't react with the food. Next, they are used in the field of medicines in the capsule. We are taking the capsule, right? The outer body of capsule is made up of the plastic. We are taking capsule along with the medicine. The medicine enters to the human body. The human body containing intestine. At the intestine, which is hydrolyzed easily, and it containing 100% biodegradation character and non-toxic character. Okay, capsules containing cap. Capsule cap is made up of biodegradable polymer, which containing hydrobiodegradation and oxybiodegradation. Next, they're also used in orthopedic devices. They're also used in orthopedic devices, and they're also used in safety belts, and they're also used in the cool drinks and etc. Right? The continuation we will see in the next class. Thank you all. The session closes, Nana. We can have very less time. The continuation, do you have any queries? We will see in the next class. Thank you.